Welcome everyone to the Real Life Machine Learning Conference organized by the team of AI42. And we are now live from Copenhagen, Oslo and Nottingham. And I am going to be the host for the next few hours together with Håkan and Goran. And before we get started, let us tell you a few words about who we are.
Yes, so basically the motivation here for starting the AI42 is because we have recognized that there is no really good starting material. So what we want to do with the AI42 is we are a strong team here consisting of 3 Microsoft AI MVPs, and we want to present you with a valuable series of lectures that will help you to jumpstart your career in this interesting field of data science and artificial intelligence.
The concept is simple and involves professionals from everywhere around the globe. There is new content twice a month that will help you understand the underlying mathematics, statistics, probability calculation together with data science and machine learning pipelines. With this lecture, you are going to be to land your dream job, as long as it's related to artificial intelligence and data science.
And by creating cross collaborations with other organizations, we can give the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we would be able to support less fortunate people and organizations that are not that recognized yet, even though they would deserve it.
And we are also very grateful that we have sponsors. So this was our organization, and also this conference is sponsored by Microsoft and Miles. And we are very humbled by all the support that we get from our contributors as well. So thank you to Levent Pongor for all the beautiful graphic content. And also it's his birthday today, so we should all say happy birthday to him. And also to Mina Marie for this cool intro music that we have before our events.
We are also...
Yes.
Oh,
sorry. Yeah. Go ahead.
Yeah, we are also in close collaboration with C# Corner and Global AI Community. So our lectures are going to be also on their YouTube channel and on our social media. Nicolette Todd creates and reviews all our text content we use on our web, advertised and during our sessions.
And you can follow us on Facebook, Instagram, and Twitter to become a part of a growing community. And this is where we will also share a lot of knowledge and a lot more fun. And you'll find every information that will bring you to an advanced level in the field of AI and data science. You can watch our recorded sessions on our YouTube channel and find our upcoming sessions on our Meetup page.
Yep, so this is our first conference, and with this we want to show you how AI and machine learning can be used in the real life. And for this we've invited 3 amazing speakers here from different industries. So we'll have the opportunity to listen to Stefan Mandaric, and he will give us an overview of how AI can prevent in-hospital falls with AI technology. And then you will learn from Goran Vuksic. He will talk about how we can use Azure Percept in real-life solutions. And then following Goran, we have Peter Larsson, and he is waiting for you with his massive knowledge and experience about real-life AI applications and how to build such solutions right from the start.
Yes. And before going to our next, the first speaker, I want to share a few information with you. So the Code of Conduct outlines expectations for participation in our community, as well as steps for reporting unacceptable behavior. Because we are committed to providing a welcoming and inspiring community for all. So be friendly and patient, be welcoming and be respectful with each other. During the Real Life Machine Learning Conference, you can win some cool things. You can go ahead and complete this Cloud Skills Challenge and in this following 2 weeks and be the lucky winner of one of the 3 AI42 swag boxes. The randomly picked winner will be published on our webpage on the 25th of September. And the learners are those who seek out ways to increase their technical knowledge. So this badge is given to anyone attending to an Azure technical session, seminars, meetups, and conferences. So please go ahead, scan this QR code, claim your prize, and enjoy our conference. So let me, or more like Stefan, start on this. Stefan fell in love with data while analyzing terabytes of microscope images for his master's degree. And for the past 6 years, he has been developing data and machine learning products across startups and global companies. And today, he's going to cover some technical and ethical aspects of designing AI systems for medical applications. And in his talk, he will show us how to prevent an hospital falls with AI technology. And if you have any questions during the session, feel free to post them in the chat, and then the speaker will answer them after the session. And if we won't get all the questions answered, we will revisit them during the panel talk or after the conference. Well, at this point, I'm excited enough to let him take the stage from me. So good luck, Stefan.
Thank you very much for the introduction.
So Stefan, you need to share your screen here. So great.
Yeah, great. Okay, thank you very much for the introduction. So my name is Stefan. I'm working as a data scientist in Meta Consulting. My background is in nanotechnology and biomedical engineering. And for the last 6 years, I've been working as a data scientist, both in consultancies and in startups. So my main interests are using data and applied machine learning to solve challenging problems in industry. So those are the kinds of projects I like working with. A little bit about Inmeta. Inmeta is a consulting company with offices in Oslo, Trondheim, and Hamar. I'm part of the machine learning department that consists of about 20 data scientists with a dedicated focus on building machine learning solutions. Inmeta is around 200 consultants, and we are spread out across machine learning, data insights, software engineering, and management consulting. Inmeta is owned by Crayon, and Crayon is a global software and services company. And in Crayon, the ML department of Inmeta is 1 out of 5 global centers of excellency for machine learning. And totally in the company, we are aiming to be around 100 data scientists, and we are working with clients creating products and solutions all around the world. What I'm going to talk about today is a product that we are building together with Norwegian hospitals, where we are deploying an IoT device and an IoT solution to prevent patient falls in hospitals. So in order to give an introduction to the problem, I want to show you a video that's been captured in the middle of the night by one of our devices in a Norwegian hospital. So it's 3:30 in the night. There's a person sleeping in the hospital bed. Suddenly he wakes up, confused, looking around in the bed, trying to climb over the rails, struggling, being very unstable. And then several minutes later, a nurse arrives. This patient should not be out of bed, alone without assistance. Patient gets the help he needs and is back in bed. And what you saw here is actually a really big problem in hospitals. It's patients that need something that are not healthy enough to walk alone, that try to step out of the bed and then fall. This is a major reason for why patients get more ill in the hospital when they fall. It's also a major reason for why people end up staying in hospitals longer than they need. And it's also a major concern for nurses who have to spend time checking in patients, making sure that they are not leaving the beds without assistance. So with that in mind, I want to present what I'm going to go through today. So the topic is this issue of patient falls. And I want to start by giving you an introduction to what the issue is, how big it is, and what is being done with it today. I will go through the hardware side of the solution we're building with the IoT device. I want to go through the AI part with the data we're collecting and the models we're building. And also I want to especially focus on what we need to think about when we are building an AI-powered product that will go out in the field and actually provide value in a hospital setting, and how that is different from simply training a model. Okay, so a little bit about patient falls. So the video I showed you, it's actually a really big problem. Hospital falls are one of the most common complications. And only in the US, there are up to 1 million people that fall in the hospital every year. And globally, it's even bigger. Consequences can be dramatic. In around 1/3 of the cases, there are patient injuries. It could be smaller things, but it could also be more dramatic things like fractures, internal bleeding, and even death. So for patients that are already ill, a fall in the hospital could make them a lot worse. And it could also end up in them staying in the hospital for a lot longer. This is a known problem, and hospitals they have programs in place for managing falls. There are known risk factors, and hospitals are already optimizing how the hospital rooms are laid out, how the environment is, and also using other practices to reduce this occurrence. But the results are not consistent. Some hospitals have a really good track record, but other hospitals struggle with tackling this issue of patient falls. On a global scale, this is a large problem, but it's also a growing problem. We have an aging population, and there will be more and more hospital stays, and the hospital system will be there will be a higher workload for the hospital system. And in addition, the pandemic has showed that you really want to, in many cases, you want to limit unnecessary contact with the patient due to infections and similar. So a little bit more about what hospitals do today. Every hospital has this on their agenda, and there are multiple fall prevention strategies. It's a multidisciplinary field. It has nursing involved, medicine, and other fields. And typically there are fall prevention programs in place that are general for all patients. And in addition, they are tailored to each individual patient. Some programs include simple things such as having a call button nearby, so the patient can call for help instead of going up from the bed. It could be things like making sure the guardrails on the bed are already there. And it could also be as simple as having these slid-proof socks when the patients are walking around. A problem that is very hard to tackle, and that also leads to a lot of falls, is what is called unattended bed exits. So this means that it's patients who are not supposed to go out of the bed alone, but for some reason they try to go out of the bed and then they end up falling and hurting themselves. And as you saw in the video, this could be hard for the nurses to detect. The patient could fall and then be stuck on the floor for a long time until someone sees this. And then this especially happens for patients that are waking up after surgery, that have to go to the bathroom a lot, that are confused. So patients are healthy, or they are mobile enough to be able to step out of the beds, but they are not mobile enough to stand safely. So these patients should always be assisted when they're trying to step out of the bed. There are products on the market today to monitor for this. One very common solution is pressure sensors. So there are sensors in the bed that measure when you move around, and there's an alarm that goes off when the weight is shifted. Another approach is camera monitoring. So there are some hospitals that have systems in place where there are cameras in the rooms and someone is watching a screen of this. So there are many attempts, many medical devices out there, but still hospitals are struggling because none of these solutions are ideal for patients and staff. One very common issue is false alarms. So for instance, these pressure pads, they could go off without the patient really stepping out of the bed. And this could happen several times a night. And this could be a real physical alarm that's uncomfortable for the patient, that makes nurses run to the station. And this is really an extra workload and extra stress for patients. Other solutions are invasive, and they're also immobilizing. So the bed sensors and the other measures in place, they result in the patients becoming too immobile and stuck to their bed. So they have issues with healing during the hospital stay. Another issue is that alarms have really short response times. So a patient that is in a hurry to get out of the bed, then you only have a couple of seconds to react. And as a consequence of this, sometimes when the bed alarm goes off, the patients have to run around to check in on the patient, and this is an extra stress. So what nurses really want is a bit more time to respond to these alarms, so they don't have to rush all the time. So in Meta, we recognized this problem with one of our hospital clients, and we decided we wanted to use new technology and AI to try to help with this issue. And during the development and during this pilot program, we set us a couple of goals. So the solution we are building, that one should be built for both the nurses and also the patients. So the primary goal for all parties is to heal the patients when they are in the hospital. It's not necessarily to keep them immobilized in the bed. So we want to build something that reduces the risk of falls, but it shouldn't really interfere with other hospital operations. So each party in the hospital, that could be the patients, that could be the nurses, the doctors, the insurance companies, they all have different needs and wants and pain points, but everyone has a common goal of setting up a system so that the patient heals the best while it's in the hospital. And fall prevention should be one of the components that supports this. So we are not the only ones working with this, and most hospitals have fall prevention efforts in place. So our goal is not to come in and replace what is already there, because a lot of things are already in place. But our focus is adding a new tool that plays along with these programs and then helps the hospitals that are struggling to build successful fall prevention programs. As I said, there is a lot of work in this field, but our initial focus is on these unattended bed exits. There is a lot of research in this field, and our goal is to utilize this research and incorporate it into our solutions and into our models. There are lots of insights about risk factors that could be included in our model development and operationalization. In addition, the unique thing about AI solutions is that they are not rule-defined, but they learn from the real world and they learn from the data. So AI gives us a great opportunity to tailor the solution to individual patients and adapt to dynamic conditions and risk factors. So these are the goals for the products we are building. So with that in mind, I want to switch over to the technical parts, and I want to start with presenting our IoT device that we are building. So our idea is built on having a device in every patient room that monitors fall risk and risk of bed exits continuously, and then can integrate with systems to trigger alarms and give insights as needed. So on the platform side, there are three main components. We are using sensors. Our starting point is a 3D camera, and we decided to go with a 3D camera instead of other solutions, because out of everything we investigated, it's the most privacy-friendly and non-invasive way of understanding what goes on in the room. We are also looking at other sensors, microphones, pressure sensors, pulse sensors, but out of everything, we believe this is a great starting point that combines privacy and signal. We were also very clear from the beginning that we wanted this solution to live in the hospital room and not on a server in the clouds. The reason for this is that we want our data to be processed near where the patient is, so that we can have good reliability and also have the opportunity to act quickly when it's needed. So we have decided to go for an IoT device that is placed in the hospital room that serves as a hub for collecting all the sensor data, merging them together, and allowing us to run machine learning models right on the device in real time on multiple data streams. We use cloud service to organize our fleet of devices. And for this, we have chosen Azure. And we use Azure IoT Hub as our central hub for managing the fleet of devices. And also we use Azure for integrating with hospital systems and also integrating with notification apps and other systems that get insights and alerting. So let's start by looking at the sensor. So the sensor we are using, it's something a lot of you are probably familiar with. It's the Kinects. It's a Microsoft product that's available for businesses, and it's called the Azure Connect. Most of us are probably familiar with Kinect from the Xbox. And simply explain what it is a camera system that has camera that measures depth information. And in the Kinect, it was used for games. So the camera could detect your pose, it could track your hands and your head. And this could be used to, for instance, play games with it. The Xbox had 2 Kinects, Kinect version 1 and Kinect version 2. So it was very popular for games, but at the same time, it was also utilized by individuals and companies that connected to the data feed from the camera and tried building solutions on top of it. This is actually where our product started. So our initial prototypes were based on the Kinect version 2. And we got some promising results, but really we struggled with the quality and the resolution of the data. So Microsoft understood this, and then they took this technology, they improved on it, and then they released the Azure Kinects. So Azure Connect is a system that does a lot of the same things as the Xbox Kinect, but it's really tailored to industry solutions. So you have a lot of the same opportunities as the Kinects, but it's much higher quality and it's much more comfortable for developers to work with. So let's talk a bit more about the Kinect and what it contains. So the Kinect is a device. It's about the size of your hand. And it's actually quite a bit smaller than the Xbox Kinect. And it has a form factor that is much easier to work with. And it's filled with sensors. One thing that we're using a lot is a depth camera. It's a 1 megapixel depth camera based on time of flight. That allows us to see what's going on in the room in a privacy-friendly way. In addition, there's an RGB camera and also a microphone array. Other things include accelerometer and gyroscopes, and also a way of connecting multiple cameras together so you can combine several signals from the room. So this camera, it runs off USB power and it connects with Windows and Linux systems, and it's allows you to hook into the data feed and analyze the systems and run models on it. So it's very developer friendly. So as I said, what's most interesting about the Azure Connect is that it has a really good depth camera. I want to tell you a bit about what this is. So in a normal camera, the data we get from it is a matrix. So it has an X and a Y coordinates and 3 channels. So each one of those channels is intensity in red, green, and blue. And together with this, we can create an image that's pretty much the same as our eyes is. But what depth cameras do is they give you also a matrix with X and Ys, but instead of giving you 3 channels with colors, you get 1 channel, and every pixel is the distance from the camera to a point in space. So the output is basically what we see on the right. It's we have an X and a Y coordinate, and we have a depth coordinate that gives us an idea of what's going on in the room. The way this works, it's actually really cool. You have in the Kinect, there's IR projector that projects a dot pattern around in the room, and this is these are reflected, and they are reflected back into the camera. And what the camera does, it measures the time it takes from the lights to travel from the projector, to bounce off of things in the room, and then go back into the camera. And this is typically nanoseconds, so it's really accurate electronics. And the result is this data that we get that is like a 1 megapixel image of the room with depth information that's accurate down to the millimeter level. This technology, a couple of years ago, it was really expensive and really hard to use. So this has been done before with stereo cameras. So that's basically 2 cameras that are spaced apart, similar to how our eyes work. So 2 cameras that look at things from slightly different angles, and then some logic to create the depths from that. That was expensive, and the devices ended up being pretty big. But in the recent years, these time-of-flight cameras have basically ended up being better, smaller, faster than stereo cameras. And now these are part of integrated circuits. So for instance, if you have an iPhone and you use Face ID, there's one of these cameras that is scanning your face when you unlock it. And if you have one of the newer and more fancy camera phones, the camera actually uses a system like this to measure depth and give you better image quality. So sensors are becoming smaller, cheaper, faster. And in the last couple of years, there are lots of use cases that are opening up as this technology becomes available. So if you look into the Kinects, this is an example of the data you can get out. Top left is an RGB color feed, so your normal camera. And the top right is the depth information. So here's been color coded. So blue are things that are closer, and red are things that are further away. Some interesting things you can do is you can actually map these 2 data streams on top of each other. So you can get 3D color video by mapping the depth information to the color in the bottom left. And you can also map the color to the depth in the bottom right. This is very interesting and very signal-rich data, but in our solution, we are only working on the depth feed, and we are disabling the color image on the hardware level. So it's never connected. And the reason for this is that with the depth information, we get all the information we need to understand what's going on in the room. And also, we protect privacy because it's impossible to identify people based on this data feed alone. So the Kinect gives us a raw data feed, but it also includes an SDK. So it has a built-in model that gives us a skeleton model of body parts that's built-in, that comes with the device. And this allows us to build solutions directly on the device without training any models on our own. So working with depth camera field, you could either work with it in 3D, but there's also a lot you can do by interpreting it as a grayscale signal and working with it as a simple black and white video feed. In order to do that, what's actually really interesting that a lot of the standard algorithms, such as edge detection, classification, they work really well on this depth feed. And in our case, actually we could build models better than using an RGB camera, because RGB cameras, they struggle with a patient that's under the bed sheets. But with a depth camera, it's much easier to understand the positioning of the patient. But there are a couple of artifacts, and this is something we handle with the signal processing. So you can see that there are some black areas, and this is basically where the light signal from the projector gets reflected many times, and it confuses the camera. It's also other things, such as black objects and carpets, or really reflective things. They also induce noise. So what we are doing is we are creating smoothing algorithms and in-painting algorithms to create a much more stable signal. And based on this, we have the opportunity to use a lot of the tried, true, and tested machine learning algorithms. In order to analyze this data, we are using an embedded computer that is, it's from NVIDIA. It's called NVIDIA Jetson. And the way I like to think of it is if you took a Raspberry Pi and you connected it to a really, really strong GPU. So what we have here is a small computer that runs off out of USB power, but it has a really strong GPU where you can do real-time inference on multiple video streams. It has an ARM CPU and 4 gigabytes of RAM where you can use simple CPU processing. It has all the connections you would expect from a computer. Yeah, and it runs on Ubuntu, so all your usual programming languages work on it. In the clouds, we use a couple of Azure services. The IoT Hub is used to manage a fleet of IoT devices. It allows us to monitor if the device is okay. It allows us to talk to the device behind firewalls. And that is really important in difficult networks in hospitals. Azure Machine Learning is the place we use to manage our data, to train our models. And it's also the place where we will build a framework for MLOps. For integrations and business logic, we are using Azure Functions. So that was a bit about the IoT device. Now let's go over to the machine learning part of the solution. So there are many ways of tackling this this approach, and what I want to show you now is one of the approaches that we're taking, and that's training a machine learning to directly predict in the future when a bed exit will happen. So the problem statement we are starting with is that we have a depth video feed, and we want to predict a probability of an event, a bed exit event in the future. So we don't want to predict, is this current frame a patient exiting the bed, but what is the probability of this happening sometime in the future? And the reason for doing this is that if you want an answer now, you can already use a direct camera feed, you can already use a pressure sensor, but there are really no solutions out there that can give you heads up. So that's a very valuable thing we can do with machine learning. We are also, in building this solution, we are setting a couple of performance metrics to make sure that the models we are building are actually useful and will result in a product that people are willing to pay for and willing to trust. So for that, the solution we're building, it cannot be, so it has to have very low miss rates. Current solutions have, they detect bad exits in 98% of the time. So we really can't afford to be any worse than this. Where we have to be better than existing solution is having a lot less false alerts. And also, we want to predict in the future, and we want to predict in a time frame that's long enough to actually be valuable for the nurses. With regards to how we're building this model, this really, in academia, this falls into a field that's called video prediction, video action prediction. And for that, there are a couple of known approaches, and we are really basing our solution out of a couple of these known approaches. So one thing you can do is you can train your model to take in a frame and then predict, okay, how will a frame look like in the future? And based on that, you can say, okay, do I predict that there will be a frame here where the person is climbing out of the beds? That's one thing we can do. Another thing we can do is we can build label prediction. So given this video feed, what labels and for what actions am I predicting? Other thing we can do is looking at motions of the patient and then predicting what sort of motions will happen in the future. Each one of these have their own requirements for how we collect the data and how we do labeling. So really picking what approaches you want to take are important before you set your strategy for labeling and data collection. So based on this, our approach, the most promising approach, is this predicting future labels. So with that in mind, we now will look into how we collect and present the data. So for the data collection process, our strategy has a couple of goals. So we need to collect enough of the right data. So bad exits, they don't happen too often. They happen maybe once or twice across 100 hospital nights. So our camera rig, it needs to be in the right place at the right time to capture these events. And we also need to make sure that we have enough data to avoid blind spots and unintended bias. We need to set up a labeling pipeline. So as I said, it's 100 nights of nothing interesting for every interesting event. So we need to have the tools in place to efficiently go through a lot of video and identify the positive labels we want to train for. And of course, for everything, we need to make sure that privacy is preserved. We want to collect as little data as possible, and we don't want to collect data for when it's not interesting for training. Empty room is not interesting. When there are nurses in the room, it's not interesting. So we build our software and our hardware to cut out the data that we will not use. And also the data that we do collect, it's anonymized by default from the camera feed, but we're also removing any associations between patients and room numbers and the data. So it's impossible to track back to who was in the room. And of course, everything is stored securely in the clouds. So as I said, this happens rarely, and potentially the models are very data hungry. So collecting enough data has been a challenge, and also a very interesting challenge. We have a couple of approaches. One thing we did really early was just setting up, when we started the pilot project, we got consent from patients to set up a passive data collection. That means a camera that doesn't do any prediction, that doesn't sound any alerts, but just collects data that we can analyze and train models on. But with only a couple of cameras and not a lot of time for the pilots, we knew that we wouldn't get enough positive labels. So another thing we did was actually go to the hospital and play doctor and patient. So we got access to a hospital room, we set up in camera, and then we pretended to be patients that sometimes we're just rolling in the bed, sometimes we're lying still, and sometimes trying to climb out. So this was a way of getting a lot of positive labels very quickly, but also a bit of a dangerous thing, because it was really, there could be a lot of bias here, because I mean, we are not experts in nursing, so we created some positive labels in how we would climb out of the beds, but that isn't necessarily how a patient would do it. Another thing that is very interesting for us is synthetic training data. So this is not an image of a real hospital bed. It's actually a simulation in Unity. So using this, we could run a lot of simulations in Unity, generate data feeds that we then use to train our models with thousands and thousands of hours of data with lots of variations. That was a bit about the data collected. With regards to what we've done in the modeling, of course, we are pretty early in this project. So we don't really have a lot of data to do the most data demanding models. But what we do is we start with solutions that don't require a lot of data. And one thing we get for free in the Kinects is this pre-trained model that gives us skeletons. Microsoft has trained this model for us as part of the Kinects. In lots of different situations with both real data and simulated data. So they have a very varied data set with a lot of edge cases that would be hard for us to capture. And this is very promising for, let's call it normal everyday situations. But what we saw is that Microsoft didn't really think of this hospital use case. So in some cases, when the patient is in the bed, suddenly the patient is in the roof. That's because the skeleton model gets confused, and suddenly there's a skeleton flying around in the room, and you probably don't want to ship that into production and trigger alarms all the time. So it was a good starting point with no data, but we quickly got over to a little bit of real patient data and a lot of bootstrap data. And we started building a frame-by-frame classifier based on a pre-trained model that was where we used transfer learning to train it on depth feed. So this is an example of the model that is binary classification based on a depth image feed that scores every frame with a risk. And using this, we can feed this data into like thresholding and other alerting systems that can trigger an alarm. So this approach is really promising, and actually you don't need a lot of data when you're utilizing transfer learning to build a system like this. So it's a great starting point, and it's a model that's very promising to be included in early tests of the device. But an issue is that our system doesn't really have a notion of time. It just takes in frames, and it classifies every single frame, and then there's some logic on top of that. So the next point would be to actually use this time information in the videos. For instance, by connecting the convolutional networks to LSTMs, or using 3D convolutional networks to understand the sequence and frames and get a stronger signal in that way. But these approaches, they are much more data heavy, and they're also more computationally heavy. So these ones are more taxing to both train and also to deploy on a device. Another thing that's very interesting is actually doing modeling on the 3D point clouds. So we have a depth camera, and the depth camera the depth feed contains a lot more information than a single RGB or a gray field that is not captured with normal convolutional neural networks. So in the last couple of years, a lot of research has come out on building classification and segmentation models on top of 3D data. That's a bit about the modeling. With regards to building trust in our solutions, this is something that's very important and something we are thinking about all the time. When we build something, how will the end users trust it? And the things we are always thinking about is, okay, our model accuracy. Do we have a good accuracy? Do we have a good way of measuring this? And are we able to convince our end users that we have the accuracy that we're talking about? Do we have the right training data? Do we have enough of it to correct for biases? Is there something we're missing in the training data? How stable is the solution? Will it get confused? And if it gets confused, is there some humans that can take over? And also, are we able to do inference quickly enough so that we can sound these alarms when needed? In addition, this is a device that needs to operate in a hospital environment in a stable and good way. So compliance, governance, monitoring is important, data security, and also integration with existing business systems and business rules on top of the model predictions. Of course, none of this is worth it without us having ethics in mind. And from the get-go, we wanted to design with privacy in mind. And this is something we've seen in the last couple of years. Systems that monitor you and are creepy are not the future of AI. And we wanted to design for privacy from the get-go. Making sure that patients are not feeling this is creepy and not being identified in any way. Bias and fairness. How will it discriminate some patients? Will it work equally well for all patients. And the last thing is, of course, impact. So we are spending time on this. Patients are volunteering to be part of this, and clients will be paying for this. Can we show that there is an impact for this, and can we show that we have a positive impact by building a solution? So just to summarize, I don't want to repeat the project, but I want to just talk about a figure that comes from a Google paper that came out probably at least 5 years ago. And it's what Google learned when they were building machine learning systems. So a lot of us are thinking that, okay, machine learning, there's a lot of neural networks, there's a lot of coding training loops and so on. But in reality, what we see is that the ML code, it's actually this small box in here. And everything around is the systems that are in place to make sure we are engineering a really good ML solution. So this is what Google says, and it's something I really agree on from as an engineer. But when I'm building a solution that's going out and solving like a real business need in the real world, there's a lot of other things that you need in addition to only really good engineering. It's things like domain experience, understanding the problem, understanding what works well, what does not work well. How will people interact with this? How do we integrate this and get it to work in an existing system? Privacy, fairness, transparency. How do we demonstrate that this is worth investigating further and worth deploying? How do we take this fancy system that spits out probabilities and sounds alerts? How do we make end users trust it? And also, how do we adapt to changing business needs? So building AI solutions, it's machine learning in the core, and it's supported by a healthy dose of software engineering and data engineering. But it's really about thinking, how do I build a product that people will like, that they will use and trust, and integrate it in a good way? And that's much more than just training the most fancy machine learning model, and also much more rewarding in my field of view. So that was it for me. Do we have some questions maybe?
Wow, Stefan, it was really amazing. It was a really cool session, and thank you a lot for doing such a good job. And yes, we do have some questions. So, for example, the first question is coming from Gabriel. That do you also look at ROI as a driver to justify the time effort of exploring an AI solution to tackle this problem?
So what do you mean with ROI here?
Well, so what do you understand from it? It can be something, I think it's probably related, because it was asked around when you were showing the camera results after the transformation.
Yeah, so Stefan, I think what he mentioned is the return of investment. How can you look at the return of investment as a driver?
Yeah, so I mean, it's a huge commercial. Like if you think of the commercial side, hospital stays are very expensive. Nurses are very expensive. We have issues with hospital systems being stretched. So there's definitely a lot of both like commercial interest in this from investors, from clients. And there's also like very important from the ethical side. I know a lot of people who actually have experienced this, and it feels so devastating. Like, you go to the hospital, you think you are safe, but something as dramatic as this happens, and suddenly maybe it's a routine thing, you're in the hospital, but suddenly it ends up being a very dramatic thing. So definitely both the commercial side, also like outside of Norway, you have insurance companies. They are very interested in these things not happening. For instance, in the US, you really don't want mishaps in the hospitals there.
Yes, of course. Thank you, Stefan. We also have another question that how far Xbox camera can detect depth. So like, and for what depth you would say accuracy is reliable?
Yeah, so the specs say from 1 meter to around 9 meters. And within that, you get like a reliable data on probably like a couple of millimeters. So with some processing, you could do things like measuring, for instance, breathing frequency. So that's also a really interesting thing. By putting this camera in the room, we are collecting like other signals, not only you're moving around, but if your pattern of breathing has changed, and that's also a signal that you're in distress. And we are starting with Kinects, but there are a lot of sensors coming out. We have time-of-flight cameras, we have radars, we have LiDARs. So cost is going down, precision is going up, and I think we will see a lot of solutions built with these sort of sensors in the future.
Yes, it sounds really amazing, and I can't wait to see what is coming next in this industry. And I hope you will keep us updated with all the news you have. And with that, I want to say a big thank you again for joining us tonight, because you did an amazing job, really. And we're going to share in the chat in a second a link where the audience can also provide the feedback about the session and about the conference itself. So you're welcome to go ahead and do that now, or in the end of the conference as well. You will find the link later. And again, Stefan, thank you a lot for tonight. Now I'm going to hand over the mic to our next moderator, who is going to be Gosha and her amazing speaker.
Hello. So before we start, I would like to say that we have code of conduct and we are committed to provide an welcoming, inspiring community for all. So be friendly and patient, be welcoming, and be respectful with each other. During the real life machine learning conference, you can also win some cool things. So complete the Cloud Skill Challenge in the following 2 weeks and be lucky winner of one of the free AF42 swag boxes. The randomly picked winner will be published on our webpage on the 25th of September. Learners are those who seek out ways to increase their technical knowledge. This badge is given to anyone attending in Azure technical sessions, seminars, meetup, and conferences. Please scan the QR code, claim your prize, and enjoy our conference. And our next speaker, next on is a bit of Azure Precept, which works out of the box with cognitive services, machine learning, and other Azure services as well with our below Goran. He works as a technical manager for Strategic. He is also a Microsoft AI MVP. He worked with notable clients like Forbes, The Next Web, and NVIDIA, and so on. Goran is a tech enthusiast. He writes technical blog posts and often shares his knowledge on different workshops and talks. Goran won't be shy to speak up, as he is already a well-known conference speaker and author. If you have any questions during the session, feel free to post them in the chat and the speaker will answer them after the session. If you won't get all the questions answered, we will revisit them during the panel talk or after the conference. So Goran, the stage is yours.
Hello and thank you. So I hope you can see my screen and presentation. I will talk about Azure Percept, and we will see some real examples. And you already gave a nice introduction to me, so I'll just say I live and work here in Sweden, originally from Croatia. I'm enthusiastic about tech. I often go to different conferences and hold sessions, workshops, and such. And yeah, I would like to share you today more about this device. I earlier worked with some similar devices like Azure Percept. You've seen one in the previous session. It is NVIDIA's Jetson Nano. I also, some of those projects I did got recognized by NVIDIA and such. So I have some experience in that field, and this year Microsoft released the Azure Percept device, and we will have a look at it through this session. So, where to start? Intelligence at the edge, right? Why do we need it? Why we need AI on the edge? And like if we look at the world nowadays, we talk about this Industry 4.0 and like there is robotics, yeah, everything is automatic. We have big data, we have AI and such. So why do we need intelligence at the edge is the question. And usually, like in the real world, those are scenarios that we do, that we process some AI models at specific location and then get the data points to the cloud, instead of sending all the data to the cloud to be processed over there. And if we take a look at the example, like this is a car, as simple as it sounds, right? But this car, especially modern cars, already have a lot of sensors in it, and every sensor produces some kind of data. And especially the modern cars, like self-driving cars, they produce a lot of data. And if you try to search for how much data is produced, I can tell you that there is a lot of different sources that you'll find with a lot of different answers. Some examples I've seen is around 20 gigabytes of data per hour, up to terabyte per day, and so on. But whatever we talk about, like, it's a lot of data that is produced. And now imagine that this data needs to be streamed to the cloud. Like, you really need a big pipe to be able to upload all this data, especially if we talk about like video data. Like, you want to know what's in front of the car, what's in backs, what's on sides. Maybe you need some additional cameras that could tell you what could be seen in a rear mirror, like, and such. So do you really need like to upload all this data and process it in the cloud? Actually, no. That's why intelligence at the edge. You run model at the edge, process data there, get important data points out, and this is what you get sent to the cloud. Even though yeah, technologies as 5G and so on enable us to stream more and do more things, get more data to the cloud, it is still a huge amount of data. And don't just focus yourself on one car. Like, you could have whole fleet of cars. Maybe you have the delivery service for the city and you want to make it with self-driving cars. I know it's a bit stretched, but future is almost there. And maybe you're not running it just for one city. Maybe you are running for multiple cities, right? This delivery service, and you want to know exactly what's going on with each one of those cars. So you could do stuff like predictive maintenance and so on. And yeah, that's a lot of data getting to the cloud. So we want to be able to process it on the spot and just send some data or raise some notifications. And Azure Percept, it's not just the device you've seen on the opening slide as described over here nicely. It is a family of hardware and software and services designed to accelerate business transformation using IoT and AI at the edge. And statement that Microsoft gave, like start your proof of concept in minutes, is actually true. This device is really simple and amazing how easy it is to set it up, to connect to the cloud, to try it out and see how it works. And through this presentation, I will show you the several of my personal projects that I did for fun, just trying out device, and I'll show you a few projects that I did on the work, showcasing to different clients or just exploring how this could be used in real life. Right. On the following link, you can check out more about device, but about whole Azure Percept. But when we talk about device, we talk about development kit, and that development kit, as you can see here on the picture, consists of two parts. One is the Azure Percept Carrier Board. It's the computer with these two antennas, and the other one is Azure Percept Vision. That is the smart camera. I have it over here. I hope you can see it on the camera. So it is in this metal case, cooler, right? And has two antennas for the Wi-Fi. On one side, there is a plug for the power. It is powered with 40 volts, which means you will not easily put it on some kind of battery, but it's not designed for that as a Raspberry Pi for comparison, right? But it's really, really strong and powerful compared to Pi. And on the other side, you can see we have a button over here to turn it on. We can plug in the network cable, we have HDMI, we have USB, and over here we have USB-C, which allows us with the cable that comes with it to connect it with the camera. This is a camera. You can adjust it in different positions as you like. Connector to the camera is under this small cooler, and yeah, basically that is it. Nice and simple, small device. This development kit can be extended with one additional part, and that is Azure Percept Audio. And this is how it looks like, and you can see it also on the picture. It is microphone linear array. It has 4 microphones over here. And on the bottom side, you have button to mute it. You have USB where you connect it, and you have the line out. So not much over there. You can see on the picture on the slide that how it's connected with this cable that goes to this Percept unit, right? And what we can do with it is this device can recognize the voice commands, process the voice commands, and give us some kind of output. We'll see examples soon. So main question that usually comes up is, okay, how to get this device? You can buy it at the Microsoft Store and they will ship it over to you. I would say I was lucky company I work for got invited to preview of this device, so I got hands on it pretty early. We got 2 devices. I'll show you some example what can be achieved with multiple devices later on. Is it worth the investment? I would say definitely, even if you are a hobbyist. It is. There are so many great things you can build, and I hope through this session I will inspire you a bit. Not that I'm selling you anything. I don't work for Microsoft or something. I just saying I really like the device, and it's worth trying it out and see how nicely it fits into the whole Azure ecosystem of services, right? So we said device and services, right? And we have Azure Percept Studio. So as described, it is a single launch point for creating edge AI models and solutions. So with Azure Percept Studio, you basically define, okay, how you want, you prepare your model, you train your model, you publish it to device and execute, and you see some kind of results over there. And what we can do with the, before I go there, sorry, I'll switch to here. And you see Azure Portal over here, and I'll show you a bit the Percept Studio, how it looks and how it works. So you can find it over here, or you can find it via the search, right? And when you go into Percept Studio, there's interface is pretty simple and guides you in a nice and simple way to be able to perform different things. So it asks you, like, are you new to AI models? Do you want to see simple applications? Do you want to do advanced stuff? On the left side, this is like an overview. On the left side, you have option devices, and over here you can see the list of your devices. At the moment, here is only one device. It is disconnected because I just showed you that device, right? And then you also have a list of AI projects that you worked with vision or with speech, and you can check docs, documentation and community, and ask for the support request, right? If we go back into the overview where we started, when you open Azure Percept Studio, you can see tabs over here. So basically this leads you to tabs. You can see demos and tutorials, and they are split into 2 parts, where you have vision tutorial and demo. So you want to work with your camera, you want to recognize something and try it out. And here you can try the sample models, or sample models will pop up on the side. You need to select your IoT hub and the device, and then you pick the model you want to work with, right? And you can also create vision prototype, or you can go to documentation to learn more. Similar with the speech, like you can use these voice assistant templates. And same way, you need to define your IoT hub where your device is connected, select the device, currently disconnected. We will go through this a bit later. Select some examples and start with that. You can also try out the sample applications like people counting, vision on edge, and there are some advanced tools that you can use, Azure ML and notebooks like a quick start is over here, and look into some other advanced tools. Basically, that is it. Azure Percept Studio is super simple. You can create project just clicking here around, and I'll walk you through the whole setup. I'll switch back to the presentation. So when I was clicking around, you've seen some simple vision models, and those models allow you to do this general object detection, like finding the common well-known objects. You can do people detection, identify people live stream. You can detect different products on shelves, or you can do vehicle detection, cars, trucks, and so on. Those are the sample vision models that come out of the box. With voice assistant templates, there are 4 of them, and one is hospitality, like example of the hotel room equipped with voice control smart devices. You probably run earlier into the different voice devices at home that you use, that you can give commands, control light, turn on, off TV and such. So basically this is very similar to that, just applied to specific industry, like to hospitalities, to healthcare, like how it could be used if patient is in bed. So a patient could give commands to close or open the blinds, right, to adjust the temperature in room and so on. There is a warehouse example with inventory, and automotive example. This inventory example I can show you quickly in a super short demo. This is how it looks. We were testing that at the office. You can see the Azure Percept is here with the audio, and you can give a voice commands like, okay, you see inventory summary of some boxes. You can say, okay, sell all the green boxes. Device does the processing of the voice commands, and action is taken. So you could see now that in a second, as the voice command is processed, there were 6 green sold, I think, and now it was filled in with the blue boxes at the end, right? So those are the examples that come out of the box. If we had a look at the video. Sorry, skip the slides. So question is, what can I build with it? And over here, I wanted to inspire you a bit with my personal hobby projects, and also some things that, like I said, we built in the company. So one of the first things that I wanted to try out, okay, how this custom vision works, like what can we do with it. And I made a small project and wrote a blog post about it. In that blog post there is a full walkthrough, but Lego had released edition of minifigures with Looney Tunes, and I decided to detect the Tweety and Sylvester to see, okay, how this works, what I need to do, and how to get it on device and get some results. So what I did in custom vision is that I created a new project, and I defined it as, okay, this is some object detection in a general domain. And For that project, I added a lot of images, taking pictures of this minifigures and other minifigures, and then to be able to tell my model, okay, this is Tweety, this is Sylvester, and there are some other minifigures. In custom vision, you train the model, right? Before that, if you use custom vision, this is how you tag your pictures. So you need to, for each picture, mark the frame, okay, where the minifigure is. Like this is left Tweety, on the right Sylvester, and other minifigures are just for example here. And once you train the model, and you can go back into the Percept Studio, and over there you can deploy model to device. So you can click which model you want to deploy from custom vision. In this case, like you are selecting the project name and which model iteration you want to deploy. Once you deploy this to the device, you are able to go and see the web stream video, and this is how it looks. So through the interface, you see web stream, and you can live move your camera around, try out different minifigures, what is detected and such. So this is a result of that probably first project. I think it was the first that I built with it, just to try it out how it works. So I decided to, if you want, there is, I think link will be pasted in chat if wasn't pasted already. Blog post about it walks you through with the whole explanation from portal going into Percept Studio, the things that I shown. When you open device, you have these options to view the stream, that's the web stream, right? To deploy a custom vision project, once you click that, you just need to select the project name and iteration, and to deploy it. There you can also capture images directly from the camera. This blog post will walk you through all the details how to do that by yourself if you are interested. So the next thing I was building with it, I took Lego Boost. Lego Boost has this smart brick similar to previous Mindstorm version of Eve3. There was a smart brick that you can program, communicate with and such. This one, Lego Boost already comes with one card that you can assemble, and basically I placed the Percept on top of it and decided to try out obstacle avoidance, how it would work. I wrote 2 blog posts about it. First is on Hackster, and that one shows in depth like how this was built from the Lego parts, then training, detecting the cones, right? And how in with use of Node.js I got the telemetry from the device, and over here you can see example telemetry what was detected. There was some cone detected with some confidence over 51%, and basically idea was when car runs into the cone, it should start turning and continue its continue the path. So this was built I would say in a couple of hours. Pretty simple. You can see Percept there, cones are detected. That's camera on top of percepts now it's Lego Boost is receiving like a turn command and continues with until there is no cone in front. Pretty simple. This is front view. It's turning. You can also have this programmable LED on it when it you can turn it green or blue, red, whichever color you like. You can see here placing the cone in front of the camera will turn it red, otherwise it's green, right? Pretty simple thing you can do for fun. I was right picture is actually from Perth, Australia. I was surprised that I got reach from Australia that someone is assembling my my project over there and asking few questions and details. So that was really really surprising thing. Yeah, like I said, custom vision, defining your custom model. This is not something that standard detection would detect. Those cones come with Lego Boost. You can detect it and try it out. Last of my projects, I haven't wrote a blog post yet. A bit of lack of time in the lately, but I got it halfway written. It is the air guitar, and air guitar is concept of playing guitar without guitar itself, right? You are just showing in the air how it works. And I posted video on the LinkedIn showing how it works. Basically, what I trained Vision for is to detect different position of fingers like G and C chord, and to detect the pick. And now when I hit the pick, in Node.js is a small backend that will figure the movement of that pick was detected, and it was moved and triggers playing the specific chord that was in that time there, C or G. I can tell you for difference of grabbing two chords, it took over 200 pictures for the chord to be recognized. So take some effort. Like most of time with this experimentations you will spend in the custom visions tagging the pictures, but that's how it is. But that also tells us how the device is great and so simple to just, okay, once model is trained and ready, you just put it on device and you are trying it out. It works great. Some things that come out of the box with those models that we have is, for example, detecting room occupancy. This is something that we were doing here at the office, showcasing the use case for the real estate industry, because if you are able to detect in your meeting rooms, like when people are there, you could find out some patterns and adjust heating or cooling system or turn off lights and similar things. So this was one example that we were doing in work, and we also explored some of the concepts like, okay, how this could be used in industry, and with use of two robotic hands, like those bolts were placed on specific locations on this table, and you can see over here is one small custom dashboard. At the moment it's visible camera feed, it's connected, but it's showing from here. Camera was placed on the top later on, and some other data that is visible here. Those things come from the Raspberry Pi, so you can ignore that. That is the separate from the Pi with SenseHead. But over here, what was detected with Azure Percept? You can see that we detect bolts that are placed. Those three are placed on correct locations, and this one is misplaced. So it's not sitting at the location it is supposed to, over here, right? So if we I can show you the quick video about it. Just a second. Here is my colleague preparing to set this up. And you can see robot hands, they are placing bolts on the specific locations. And later here, you can see this detection happening. This one is misplaced. Those are 3 now correctly placed bolts, right? Could be useful scenario for the industry. Getting back to presentation and going step back to that room occupancy example. So how do we actually analyze the room occupancy? We have the Azure Percept device. At the moment here is only camera, but there is device over here that streams data to IoT Hub. We've seen that example of telemetry I showed you in the example. So data is streamed to IoT Hub. So how we can use this data? We can connect stream analytics to the IoT Hub, and for example, we can stream it to Power BI. And I will show you how that is done. So when we want to do this kind of project, we can use the standard model, people detection, and publish it on the device. In few seconds, you can get it running and see that there is detection of people happening in front of camera, and whatever is detected is streamed to your IoT Hub where device is connected. So in order to stream data, we need to create a new stream analytics job. So we defined it via the name, subscription, resource group, location, and so on. Once you define the stream job, you need to define where data comes from and where will it go. So input and output. In our case, on the left side over here, we would define input as IoT Hub and enter the values for our IoT Hub. And for output, we would define Power BI. So data will be streamed into the Power BI. Once we define input and output, we need to define, okay, how this job looks like and what we are actually doing. So we define this with this SQL kind of language where we select from our stream input into stream output. We define some conditions like neural network is not null. So some kind of detection happened, right? And we are getting the array length because it's people detection. It's giving us either no detection, 1 or 2 or 3, how many people are in a room, and gives us the detection and send this data to the Power BI. In the Power BI, you can create a new report, and in that report, you can select the data from the table. Over here you see I have Power BI Percept table with some person count and with time, because I need to know when this detection happened. And over here you can see some detections that were happening, like from 1 to this is 2, right? And I think if I see this correctly, this is like over some 3 minutes. Tuning this a bit, you can adjust it into real Power BI dashboard. You can combine multiple data sources and such. We have like 4 meeting rooms that are displayed over here, like where we put this device on top of TV. And as I said, we had 2 devices, so we did 2 by 2 rooms to combine the data to showcase how it could work. And then we could group group the data and show when the meeting rooms are actually used and how many people are using them. And based on this, we could, for example, see maybe room 2 is not used before noon. So that means there's no need for heating or cooling over the summer, right? I can show you quickly that example over here in the on the link. You can find the full explanation how it works with additional details, how everything is created and how to make solution of your own. And here you can see this is a room, that meeting room that was sketched in Power BI. Azure Percept sits on top of TV, and what it does over here, it detects when someone enters the room, and you will see that detection happening now in a second. Here, for example, I'm entering the room, right? And there is person detected. So that was it for me. Thank you very much. Feel free to connect and feel free to ask any questions.
Thank you, Goran. It was really, really great to listen about this AI and IoT together. I really enjoy all the things and that you can use Azure Stack and you don't need to write any Python code and use a lot of data science. So I have a question to you. Can you use Azure Predict Studio without Azure Predict devices?
Azure Percept Studio. Yeah, you need device to connect there to be able to deploy, because as I shown, there's not much to be done in Studio. Everything, if you want to do some custom detection, you prepare the model in custom vision. You can do that without device. You can take pictures with your phone camera or something, or computer camera, and you can test it over there, right? But once you have device, then you go into the studio, and only thing you do, you connect this device and say deploy this model to device, and it does detection.
Yeah, because this what I'm thinking is to just start as costless as possible and just try this one before you buy a lot of stuff. And a lot of people really enjoy your presentation. And if you will have more questions to Goran, we have a discussion panel after Peter's session. So feel free to just write more questions, and Goran will be happy to answer them.
For sure.
Thank you once again for the really, really great session.
Thank you.
So I'm going to give now to Håkon and our next speaker, Peter.
So welcome back again here. So before we start here, I would just like to remind you that we have our code of conduct. So this code of conduct outlines the expectations that we have for participation in our community. And there are also steps that you can take if you want to report unacceptable behavior. So we're committed to providing a welcoming and inspiring community for everyone. So be friendly and be patient, be welcoming and be respectful with each other. I will post the link to our code of conducts in a short while. But in addition to this, we also have a real-life machine learning challenge, a cloud skills challenge. And if you participate in this, you can win some really cool things. So if you complete the cloud skills challenge in the following 2 weeks, you will stand a chance to be a lucky winner of one of 3 AF42 swag boxes. So we'll pick a winner randomly among the people who have finished this cloud skills challenge, and then we will publish it on our webpage on the 25th of September. And we'll also share this with you in a short while. And then finally, we also think that we want to celebrate the learners. So learners are those people who seek out to increase their technical knowledge. So we have a learner badge for anyone who's attending an Azure technical session or seminars or meetups. So please scan this QR code and claim your prize and enjoy the conference. So with that said, I would like to introduce our speaker here, Peter Larsson. So Peter Larsson is an entrepreneur and a visionary business developer with almost 20 years of experience from data and AI. So he's been working both in startup, in research, and in large enterprise environments. And over the years, he has gained a lot of experience from multiple industries, both in healthcare, retail, in manufacturing, in finance, and in the public sector. And he has also been responsible for deployment of exciting new applications that can range from both demand planning, predictive maintenance, recommendation engines, IoT, and also digital twins. So today, Peter will present how Avanade can help their clients becoming more data-driven through some exciting real-life applications. And as always, if you have any questions during this session, feel free to post them in the chat and we will answer them after the session here. So with that said, I will add your presentation here to the stream, and then I just hand it over to you, Peter.
Thank you so much, and it's a very big pleasure to be here. Can you guys hear me and can you see the screen?
Yes, we can hear you and see the screen.
All right, perfect. So, as I said, it's a pure pleasure to be here today and talk about how AI applications can be deployed in real life. And with the end in mind from the start, we can almost guarantee a successful deployment, moving away from, so to say, pilots to actually scalable deployments. So without further ado, I will continue the presentation. It will be a little bit different than the previous speakers, which have been fantastic. Big applause to you guys. Thank you for that. Extremely interesting, I must add. Today, I will go through a couple of things. That is why people are investing in AI today. Not only people, but the large enterprises. Why do they want to become a data-driven enterprise? And what are the challenges in scaling the AI applications? AI strategy. Do we have any tools that can help us in order to make a scalable deployment a success? And also, of course, the thing you probably want to see the most, some real-life AI applications. I have them, as you can see, in the last part of my session. So I'm guaranteed that you will listen to the first 4 bullets. All right. Thank you for the introduction. So I don't need to bore you guys with that. So I will skip this part. And then go into why become a data-driven enterprise. So there are a couple of things on why we are where we are in terms of companies investing in AI. When I started out somewhere around 2004, and I bet Goran also can bet on this, is that no one knew about machine learning or AI. And when I talk about no one, I mean, of course, the CEOs, the senior management, the stakeholders. And it's the companies today, I mean, why are they in business? They are actually in business, if you are very clear, they are in business to build shareholder value. And what I want to show by this picture is that the easiest way of doing this is to invest in AI, in getting data accessible, and of course, in different machine learning capabilities. And as you can see on the picture here, there is, if you want to be successful and basically not die out as a company, you actually really need to invest in becoming data-driven. There are a few forces in the making and drivers that are main focus for companies to become data-driven. One of them is to increase customer experience. In the past, companies have been very organizational-centric, meaning they have put the organizational structure and producing products as the most important part. They produce products that we should buy. Then we have developed to a more customer-centric focus, meaning we try to understand what is it that the client want, what the customers want, and based on different qualitative analysis, we have tried to adapt our offerings or products to the client and to the customers. And most companies are in that area today still. In the future, and actually a lot of clients and customers I'm working with today are already in this end, the embedded customer experience, meaning that today customers, consumers, as well as business-to-business companies are working and are experiencing different needs and on different platforms, on social media, of course, and so on. And all of these different types of systems that they engage in and platforms and so on create a lot of data. And in order to find patterns and understand the customers and what they want, and also actually predict who wants what and when, and what actions we need to take in order for them to actually understand that, receive what we want to provide, is through using AI and machine learning. Another driver is to increase the operational efficiency. The operational efficiency is usually looking at different processes internally in companies. It's the manufacturing process. It's of course the production. It's purchasing, procurement, and of course sales. How can you increase the efficiency within the company? Can you automate and so on? So automation is a big part, of course, for every company today that wants to become data-driven. I will go into this and I will have some not references only, but client cases that I will show that are to the point on these two topics. And also on this topic, actually, which is the third biggest driver, and that is innovation. Companies today needs and wants to innovate and to stay relevant with clients and customers. They want a lot, as you have all of us on this call probably know, is that our buying behavior is changing a lot. We are moving away from selling pens to selling stories. And how do we do that? Or from cars to subscriptions and travels. So, and in order to do that, we need to use data in order to innovate. And before, this haven't been actually so much possible, because I mean the cloud is actually driving a lot of this, of course, because there is so much data that is needed and unstructured, and it takes forever to calculate and process. But now we can actually already do it. And I know that all of you guys on this call, you know about this, but it's important to set the scene a little bit for where we are going in this presentation. So the three drivers are increase customer experience, increase operational efficiency, and drive innovation. And basically, we do this in order to not die out as a company. What are the challenges in scaling AI applications? I mean, are there any challenges? Yes, of course there are. And there are many. As you know, many pilots never become full-scale deployments. Why we don't see so many, so what I'm trying to address here is why we don't see so many real full-scale AI deployments in the real world, so to say. And the challenges, if I put them on a high level, is that there is a lack of end in mind when doing pilots today. And when I say pilots, I mean we're talking about MVPs, we're talking about POCs, proof of concepts, that is prototyping, and it's companies are using these different synonyms, which are not actually synonyms, but they are completely different things. But in almost every company I come in, they are working the same or doing the same mistake. They found something fantastic, and they want to see if it's possible to actually get the output that they are looking for. But usually, and usually they actually do, but they can't move away from there because it's too expensive. They have used technology that is not in par with what the IT department wants to work with. They use programming language that no one knows except probably the consultant company. But there are also other things, which is the internal politics. If you have an end in mind when actually going into a pilot or an MVP, you are looking at, okay, if this is a success, what do we do with it? Why do we do this? If we are not looking at doing this in full scale, if it's a success, why are we doing it at all? However, I know there is this balance, or not actually balance, between exploit and explore. In my view, companies need to explore a lot more than they exploit, of course. But there has to be some kind of balance there, and if you don't have end in mind, you will have a hard time setting the scene for full-scale deployment. So, because there are people, there are politics, there are processes, there are way of working, and things like that, taking a shortcut, not taking those into account, actually provides a big problem and a big challenge. So have end in mind when you do the pilots. Then we talk about the people, process, and technology. And that's, I mean, management consultants, when 2014, 15, when we started to talk about the digital transformation and becoming data-driven, there were a lot of clients talking about, we need, you all know the pyramid where we have people, processes, and technology. And no one then spoke about data, because the management consultants actually didn't know so much about the need for becoming, back then, digital transformation was the buzzword. Data-driven came a little bit later, and then they adapted. So now, thankfully, most clients, most companies have understood how important it is with data. I mean, without data, we can't do what we love, right? We can't do our own models. We can't experiment. We can't prototype. So we need data, and that's where we are today. A lot of big, large enterprises are trying to get data and make it accessible for people, fantastic people like yourselves, data scientists, and machine learning engineers, and so on. And I think that is great. That is so great. Then we have friends. What do I mean by friends? I mean, basically, third parties, like suppliers, partners, interest groups, and owners. Most of these have something, they are involved in your pilot, and they are involved in your in scaling your AI application. And it's important for clients, for companies, to choose partners carefully, I mean, there is a trend working of working closely together with startups, and I think that is extremely good. Coming from the startup world myself, I think it's a best way of being in the forefront of things. However, I also know that there is a problem if you want to grow, if you want to scale. You can't put all eggs in that basket, and they also tend to not work so much with the old technology that the big company is working with the IT, what the IT department is working with. So usually there is a discrepancy, or it becomes a discrepancy. But there is, in my world at least, there is room for both the startup flexibility and the scalability of a company like the company I represent today, Avanade, for example. And I think smart clients work with both of these in a good balance. And yeah. Then there are some do's and don'ts, just to trying to be very clear here. And in mind, we have touched base on that. Basically, what should we do if it's a success, right? Then a success criteria is super important. Usually, that is a little bit oversighted. It's not defined clear enough. At Avanade, we have actually, because of that fact, we have developed something we call a value tracker, which is looking at the business value that we are trying to get, and see how well we are delivering on that, through the entire pilot. And then, of course, there is a plan to scale. Of course, adopt technologies that scale. Maybe you shouldn't use, for instance, MATLAB, which is working really great, but there are not so many companies that will use that when scaling. I'm a big Python lover, but I'm sure most of you are as well. And I would say not to programming language that's very good, and can't get wrong. But a lot of clients are reluctant because they don't have that ability. They don't have that competence of building AI models or use or productionize pipelines in Python. So it's there is a gap there that needs to be addressed early, I would say. And of course, we're talking about the user interface, not the user interface so much, but the interface with existing systems. It has to be able to speak really good and really well with internal, with existing systems. We've been covering the trusted partner thing, communication. There have been several engagements where big companies have started off doing things, and they haven't communicated this. They haven't landed this internally. So actually, people get afraid. They get afraid this AI thing is going to take my job. So usually it's the middle managers that gets very, very afraid because of what I just said, losing the job, or lose control, or lose their power, basically. So in order to make them, because they sit on a lot of domain knowledge usually, in order to get them invested and inspired, it's very important with the communication part, the education, the training, and so on. Otherwise, you will never be able to change the behaviors of thousands of people, which is what a scalable AI solution many times have to do. I've been covering the don'ts, basically. Launch an AI pilot to see if it works. is basically the opposite of end in mind. So yeah, and the things that we should look out for are the black boxes. Actually, some years ago, I must admit, I told clients that they actually shouldn't care so much. If the model performs better, then and we can validate that, they shouldn't care so much. They take the result and be happy. But today, I think it's so important that we actually have to have some kind of very good explainability of the models we produce. And now, when the EU Commission is putting a proposal in place on that we have to, I think that there will be less lock-in effects and less black boxes around the world, at least in Europe. Bring IT with you. One of the coolest things with helping companies become data-driven and do these kind of pilots and do these kind of projects, to me, that is building the bridges internally with the clients, because you have this cross-functional teams that are, before that was a word that happened. And you sat down with the IT, you sat down with the business that wanted to do something. IT, we need IT to bring the data, we need IT for this and that. And it really built bridges internally. And this silo-based things that have been for so long, I think a really data-driven company have very few silos still. But the legacy companies, of course, do. I mean, hell, even we do. Then, do we have any toolkit for success? In my mind, that is what I call an AS strategy. Using an AS strategy is helping you guys, you clients, to actually prioritize between your use cases. In this previous slide, on the below button from the don'ts, I say don't choose the toughest, most obvious use case. Maybe you shouldn't try to, for instance, in healthcare, a lot of, or most cases are looking at predicting cancer, predicting stroke, or something similar, right? Looking at the operational part of it, the surgical part of it, and that is the toughest thing you can do for several reasons. Of course, the validation process of those models are huge, and also who will it's the same with the car. Who will rely on a computer in terms of getting the right treatment, and so on, and there is the legal issues and so on. So in healthcare, they would have come a lot further in terms of AI deployments if they have looked internally to actually use machine learning to optimize processes instead. I could give you a lot of fantastic examples of that, but we don't have time. In terms of a strategy model, a tool that works really, really well is something I developed together with a few professors when I did some research during 5 years on how companies should become data-driven. We call it the data science delivery model. And what it does is actually helps you as a client to discover use cases. It helps you to understand the complexity of these use cases using what we call the 4 forces of impact. And then also via the use case matrix, you get a very, very nice visualization of which are the low-hanging fruits, which are the ones that we should go for, which are the ones that require a lot from the business in terms of organizational reorganization. And of course, then we can establish a roadmap for the AI initiatives. All of this sounds logic, I would say, but it's not. Mainly because it's big organizations or very complex organisms. And also they get a lot of information from different consultant companies. This best practice method with a very, very cheesy name, Analytics Jumpstart, is a best practice method that is published. It's based on a CRISP DM, which is data mining, and is wherever we have used it, it has been very, very successful. What it actually aims at is to understand the different, define the business needs and the business value you are looking for, and also very early understand if the data can actually deliver on that expectation. Then you start to prioritize between the discrepancy between the data and the business value that you want to achieve. Then you start the modeling, you start in the evaluation. Usually the evaluation process here is a pilot. And then you can deploy it full scale. So a couple of AI applications in real life. I've chosen 3 at this point. And yeah, without further ado, so this is an AI for innovation at a leading accounting firm here in Sweden. They had, when we started working with this firm, they didn't have anything actually. They didn't have even reports, BI reports. So it was a big journey, but an extremely fun one. What they wanted, even though they were the leading accounting firm, they still are, they wanted to move, or they wanted to use data to increase the customer experience and be better at giving them advice, detect certain important patterns that can occur. So they have this amazing data set actually from around 50,000 Swedish companies that are updated daily in terms of economic information. How basically the company finances, and so we started to look at this, and actually from the beginning we wanted to understand how COVID had what was the impact from COVID in different industries, in different sectors, and so on. So we started to look at, okay, can we actually do like this? Can we understand the unemployment rate, and can we make industry comparisons? What is the ripple effect if a company goes bankrupt of this size X or of this size over here? What is the ripple effect of that? And when countries delivered crisis packages to big companies and so on, what effect did they have, and what were the ripple effects of that? That was what we wanted. But because of COVID, for some reason that I'm actually don't know exactly, when we started to look into the data, doing the data understanding, following the Analytics Jumpstart method, we saw that you guys don't have any data from the last 6 months, basically the COVID time. So, okay, what will we do then? But you actually do have, what we found out is a lot of the other interesting data from prior to that, but it's not COVID questions, COVID output that we will get. Okay, so what can we do now with that data? So we looked at it, and we could understand, okay, we can get very interesting KPIs and insights on a country level, on an industry level, and also on a corporate level. And using that, we could do some performance analysis and risk analysis and expansion analysis. And using these type of ideas, we could help them create new business models. Of course, all of this is done very much together with the client. And we came up with something really interesting. Of course, I mean, one of the things was to detect bankruptcy, the risk for bankruptcy. Another one is what are the detailed factors that are different for successful companies and more and less successful companies. And that was super interesting to be able to, all right, we can actually build a service on this. So they are now looking to scale this and deliver it as a service to clients, meaning that one, you can help as an advisor. We can help you to understand what factors you need to look at in order to move away from being have a very poor margin to increase your margin, or as in this case, where do you want to do your next expansion, in what area of Sweden, and so on. So a very interesting new service from them. Here, completely different. We are using IoT and digital twins in order to create the smartest building in Northern Europe. This is in Norway, and it's it's 80,000 square meters office building, and it's fun and a lot of things, as you can see here. This is the device landscape overview. So as you can see, there are a lot of different logos on this here. All of these logos have a stake here. You have parking, as you can see. You have toilet paper stuff. Here you have lighting and so on, and electricity, of course. So all of these are different types of integrations we have had to do in order to create a representation of this huge building. And we have used a use case approach. So we are right now in the moment of looking at the energy consumption and also parking. So the idea here is to build a lot of services around this office building. So if you have a car or if you have a bike or whatever, when you should actually be able to basically directly go to your parking lot or where you need to park your bike, etc. And a lot of other stuff internally in this building, of course. I think a lot of you guys are interested in the technical design of a thing like this, and it looks a little bit like this design here. As you can see, we use data factor for move data. We use data lake store for storing data for more reporting purposes, but blob for the more unstructured data and semi-structured data. We have Event Hub to keep track of the different streams here for stream analytics, and we use Power BI as the dashboard tool. I will continue. So the digital twin representation, it looks a little bit like this. We have a BIM model and a BIM supply we're working together with. And what we have done is to make that a representation of that, basically. That looks like a little bit like this. I am not the expert on this, so I will not try to be. But what we can see is that we can go from a very, very high level into an extremely detailed level and understand, for instance, the energy consumption in a certain room, or how many people are in a certain room, in order to be able to, if there is no people in a room, the light should go out. If there are people in the room, depending on how many, it should be X warm, or we could lower the temperature, etc., etc. And that also goes for how warm it is outside, or cold outside. And the same thing here goes for the parking, going down to extremely low level in terms of where there are parking lots, of course, but also sorry about that. I will move quick. Hold on, I will put on my hat. Up, back. Then we have an international brewery that we work with, and they wanted to use data and AI in order to come up with a smarter sales process. There's not so much, I wouldn't say innovation, but definitely automation and smartness involved, using custom computer vision and virtual agents as well. First of all, we have what we call a shelf image recognition. This here is what it is actually that before, the sales representative needed to go around with his pen and paper and write down what was missing, basically. Now, using his phone, he will be able to just take pictures, both of the shelves in the store, but also of the shelves in the, as you can see, in the storage room. And it automatically will detect what type of SKU that is gone, meaning article, and how many that we need to replace them with, or how many we need to reorder. We can also see how, or they can actually also look at in the store, the competitor aisle, so to say. How much space does the competitor have? And all of this is allowing them actually to become more of a advisory sales representatives than traditional sales representatives that just want to, okay, here's what you lack, let me provide you with an order. So here you actually can both gain efficiency, you can connect with the client or the customer in a much better way, being the advisor, and of course then also you can work offline, as you can see here. The flow of this is that you prepare the visit, you go to basically to the visit to the store, you do the outlet execution using the shelf image scan, then you get a validation. And I think it's very funny that it's a red cross here, that the picture didn't go through, but yeah, interesting. And then we have a shelf measurement, basically that calculates the market share of in this case Heineken products. Then we have a Power BI report, a dashboard that the sales representatives are trained to understand, and they can use this to show the clients, and that has been a very successful part. And Eva is actually part of Eva, the host for today, one of the hosts for today, is part of a similar journey at a client today. Then we have another thing, and this is the last thing that I have. It's a virtual agent, and it's Freddy. And as I told you guys, there is a lot of power in automation, which all of you probably know, but this is a kind of cool way of doing it. So they have this app with Freddy, and what it does is that it automates simple tasks. It provides important reminders, not unimportant reminders, I might add. And then it can respond, interact with people. So basically, it takes down the administration time for the sales reps a lot, and of course also increase sales. The promotion flow basically is like this: that you onboard the virtual agent. What you get is the Freddy provides you with the latest promotions that is maybe of interest to your customers. Then add an outlet. An outlet is a store in this case, and you see receive an approval, and then you create a visit. So it automates an entire sales process. And talking about before, what is the easiest way, the low-hanging fruits? Like, I mean, this is a low-hanging fruit in terms of, well, it's in terms of how important it is and what it can provide, but it's not a low-hanging fruit in terms of how much work it is and actually change the entire way of working for a sales agent in this case. So there is a lot of education and communication going through this. And that is only one of the agent flows that we have in here. So we have one thing that we call closing visits, which supports the sales representative in closing the visits with the clients. Of course, get the order information and the payment proposal. And one thing that all sales reps hate is to update the master data or any updates with the client. That is done much more automated today. That is actually all I have. And as I just want to bear with you what Stephen Hawking said, it's all right to make mistakes. Nothing is perfect. And because with perfection, we would not exist. And I absolutely agree. Fantastic, man. And I thank you all so much. And I hope you will have a fantastic day. Thank you.
Thank you so much, Peter. That was really, really great. So now we have some questions here for you. But before we do that, we can post a link to a survey for your talk in the chat here. Yes. So we got some questions here. One moment here. Yeah, so one of the questions is this one. Oh, sorry. One of the questions is this one. So how much time did it take from the idea to implement some of this in production for your clients? Like, for example, this shelf recognition example that you had.
Yeah, so the shelf recognition was, first launched as a pilot, but with a few sales reps involved. So they were heavily involved in going to clients. There was a client involved. So the pilot was 2.5 months, and we are still working on the implementation part of this. The implementation is done in Microsoft Azure, using different tools as I mentioned, computer vision and so on. And it's Power Virtual Agent that is used for Freddy.
Okay, thank you. And then we have another question here. In your opinion here, or in your experiences, which industries are more interested in applying AI solutions?
at where we are today, I would say that all of them are, but looking historically, where we have where it has been very low, I would say in the financial sector and in healthcare, but both of them are really coming out of the starting blocks. And when I say the financial sector, I absolutely don't count in scoring as AI applications. I mean, they have both healthcare and financial sector have both used SAS for many years, or SPSS or something, and have had researchers. So, but the most common ones, I mean, the ones that have come farthest, that are in the not so to say not legacy companies, or is I would say in automotive industry, manufacturing industry, and I'm not taking into account also RPA or anything like that when I talk about AI implementations. To me, it's absolutely something that has to be in there in the mix, but it's not an AI solution in my mind.
And then I also have a comment or a question to you, because you had a comment on Stefan's presentation about the ability to detect falling out of beds at hospitals, and about the return of investment. Can you say a little bit about that?
About that, the return on investment on the ones I showed, or the return on investment on his?
No, I was thinking more of the return on investment on what he was talking about.
Yeah, absolutely. I mean, at least in the Nordics, not so many. There are not so many. You don't count lives in money in terms of revenues. But you absolutely. I mean, the return on investment when it comes to healthcare is huge. Falling out of beds, being able to detect that. I mean, I did a quick Google search for it, so it's 14 billion Swedish crowns per year, I think it was, and which it costs society. So, I mean, the ROI for that it should be quite easy to get that budget through, if you ask me. But politicians, I'm not a politician.
Yeah, sure. Yeah, so I think we don't have any more questions here from the audience. So then we will just take a small, maybe here is a question here. Yes, one more question. So the question is, in your experience, what is the key driver to boost digital transformation in the Nordics? Is it culture, technology, data, or other things?
By boost digital transformation, do you mean to like speed it up, or
I think he's meaning to increase the digital transformation, or to increase the velocity.
I think that actually the biggest problem, or one of them, is that there is a huge lack of understanding of what it takes to become data-driven in senior management in the Nordics. So there is an education that has to be in place for them, or they can make room for people that know what they're doing. And also, and making room for people that know what they're doing. I mean, they could hire someone that knows what they're doing, which they are, but then also absolutely they must provide both budget and patience for that person in order to actually come up with a with a good strategy for them. Today, I see a very short lack of patience, and so there have been for several years, and how should I say, they're trying to take shortcuts. I wouldn't say that. I mean, Adobe is a fantastic system, but I wouldn't say that Adobe is like the way to become data-driven in terms of for a marketing department in a big company. It's also one piece of the puzzle, but it's an important piece, but it's far from that. So to boost digital transformation, I would say that the senior management needs to understand better what it actually is, and how much it not how much it costs, because that varies, but that it actually costs both time and money. So yeah. Thank you.
And what do you think? What is the most difficult challenge here? Is it more the technical aspects, or is it more the organizational aspects?
I think there is a very fun image of Pac-Man on the internet that culture is eating. What is, I don't remember what it says, but it's true. I mean, culture is actually eating everything. So that's why I addressed that topic of very early. Start talking to the business, start talking to if the business is driving the initiative, start talking to IT and so on, start engaging with each other, and if you have a data-driven sales program going on, or you have to really start talking to all of them involved in sales, to understand what this is. It's not a cost-cutting program. It's a revenue program, or whatever you want to, what the message should be. But it's super important.
Yes. Yeah. So see if there are any more questions here. I don't see any more here. So I think we can make a quick transition here, and then after the transition, so stay on the line here, because then we will be up for the panel debate. So if you in the audience have any type of questions for any of our speakers, so just put them in the chat. And thank you once again, Peter, for a very interesting presentation.
Thank you, guys. Thank you, everyone.
Yes. So then you're on mute, actually. Now.
Hi. Yes, like always. This is how I tune in all the time. I get started by being muted. But I'm so happy to be back. We heard some awesome sessions today. I would really like to hear from the audience which one was your most inspiring one for your opinion. And let's see. I think we could get started with questions, right? So we also wait for questions from the audience, and we also have some questions for you prepared already. So should I go ahead with the first one?
Yes.
So what is the biggest challenge for putting machine learning into production? Anyone can answer.
All right. The biggest, there are several. The biggest is different from company to company. If you, for instance, use Python and you don't have anyone in the client that knows Python, that could be a great challenge. You know what I mean, Eva?
Yeah.
And then, but then, if you have made your pilot, for instance, in if you've used Google for your pilot and your IT department loves Microsoft, then you have a problem as well. So it's different from company to company, I would say. What do you guys say, Stefan, Goran, Kosya?
Yeah, I would agree. Like some things like that, also proving that things work, right, and that actual results will come out, and yeah, that could be a challenge. Actually, developing something like development time can be long until you get some results accuracy, what you aim for, to be able to get it to the real system to help out there.
And it's about how to the systems as something that until it's strange ways.
Wow,
Yes,
you sound like a robot here.
Yeah.
Did you switch to your artificial intelligence?
Maybe if you have just a headset somewhere, Stefan, and you can try that. No.
It's still very robotic.
Yes.
Not getting better.
But you're from
Maybe
Norway, right?
Yeah,
Yes,
we can take another question here in the meantime, maybe. So another question here is, in your experience, what do you spend most of your time on in a machine learning project? Is it on the data analysis part, or is it tuning of the machine learning algorithms, or is it actually more the software part, getting this API to work?
I would say it's always cleaning the data and like. I think, Peter, you mentioned the Pacman somewhere or something like that, and for me those projects are always like, those data and just feeding it in. Stefan is back, so hopefully connection works.
Am I still sounding like a robot?
No, you sound awesome now.
Okay.
I thought you would actually say, Peter, that the longest time it takes to get a good understanding of what do we use machine learning for, actually. Not on our side, but during the conversation with the client sometimes.
Usually that is not the case. I know what project you're referring to, Eva, but usually I don't see that is the case. But I'm very much is in line with what Goran said. I mean, cleaning the data, get the data, understanding the data, all of those things are what takes most time. It's actually very similar in terms of 80-20 rule for a BI project. Usually, but a big difference is the bias thing in terms of machine learning. Because in a BI project, you don't have, or looking at data and data quality, you don't have to take that into account. But in a machine learning project, you really have to take that into account, because otherwise you will get very skewed results and output, and a little bit depending on what you're doing. Predicting a maintenance fault, of course, doesn't matter so much, but
Yes. And Stefan, do you have any comments? So the question was where you spend most of the time in a machine learning project. Is it in the data analysis part, or is it tuning of machine learning algorithms, or is it more on the software part, getting the API to work?
Definitely the data side. Definitely, yeah. And I mean, it's on multiple levels. It's if we have existing data sets, then it's getting those data sets. If we're working as consultants, it's cleaning it, understanding it. If we're building data from the scratch. It's building the systems to collect that data. But I mean, unfortunately for us, but luckily for our clients, a lot of the value is just getting out the data, stress testing the data, getting the basic insights. That's where a lot of the value is. And typically the clients that's their maturity level. And it's also easy to deliver value on that. And it's easy to build something that will last and that can survive when the consultants leave. And it happens time after time. I bring a single variable plot into the steering committee, and we spend 10 minutes talking about that. And yes, they think my model was nice and all, but that single variable, that suddenly triggered an initiative. So yeah, we're still early.
Yeah, I must say something that is quite funny. I once had understanding the result and the output from a model can be hard and tricky for someone that is not used to looking at data in that way or understanding it. So I had a client once. So he's like, so is this? We present a confusion matrix, and so is this good or bad? Should we go or not? And I kind of had like I had come out. I didn't have any words left to try to explain this. So I basically said, and he was the vice president of the company, like deputy CEO, sorry. And I had to say to him, like, if you don't proceed here, I would actually say you're quite stupid. And he proceeded. So that was funny. You have to sometimes just put it out there.
So based on that, how did you convince your customers to use machine learning?
Well, tell them that they're stupid, of course, if they don't. No, I feel I talk too much here, but today I would say we don't have to convince them to use machine learning so much. We have to basically convince them to work with us rather than Stratitech or in Meta. Because today you can actually read about artificial intelligence and machine learning in the daily newspaper. Everyone knows that we need to work on that, but they don't know how. Or what to look for. So that's not a problem usually, or at least not that I feel.
I think that there's that part where we need to inspire the clients and give them some idea what is possible, because they do know AI, machine learning, those things are there, right? But how that can benefit their business and what business value it brings at the end of the day, right? Why should they invest in those projects? And especially as we said, as a consultant, it's always important also to estimate. And for those things, sometimes it's not easy to estimate, okay, how long will it take to get some result out of the whole thing. So just inspiring them and giving them idea, okay, those are possibilities. And then once they are down that road, they can figure out, okay, now we are getting these results, we can get something else out of it and drive them there. First step to actually get the go is the hardest one, at least that's my opinion. Like for them to have courage to start, and afterwards, yeah, it's easier. So that inspiring part is important, I would say. And maybe for you, Stefan, it's not easy to convince, like, okay, we should install this in the hospital, right? Like why should some hospital put it in a room? Like, Just for you to collect the data first to be able to show the results. And
yeah, because we are in this situation. Of course, there's huge ROI if you start from scratch, but we are not the first ones doing this. There are other technologies out there, other vendors promising stuff. We need to show that we're better than state of the art, and that's basically how I when I deliver or build machine learning models. Typically, I start, okay, here is a problem. Here is how I can evaluate the value of a solution. What happens if I randomly guess? How much money are we making or losing? Okay, that's one benchmark. Second one, what if I spend half a day writing a SQL query? What's the value of that? What's the value of me spending one more day and then putting this data into AutoML? Yes, you're going to spend a lot of cloud money, but that's a lot cheaper than consulting money. And then, building something custom on top of that, what is the additional value? Sometimes you stop at that simple SQL statement. Sometimes even a perfect model does not make business sense. So it's always like benchmarking against something.
Yes, and I think somehow I just got some connection into my next question. So because we were talking about that what is the aim? What do we want to change while using machine learning solutions? So, you know what I want to ask, like, what kind of projects your customers want to use machine learning for? For example, I mean, what is the kind of project, like, is it for more like a revenue increase? Is it for, so what is the type of project that they are usually coming to you saying that okay, we want to do this and this because we want to reach this and that, or we want to achieve this and that?
Maybe I can give one interesting example here. We work a lot with public transport vertical, and somewhere beginning of the year there was a solution developed to make predictions for the bus and trains occupancy, public transport occupancy, and it's widely used, right? When you want to buy a ticket, you see, or you search for the next route, you see how much predictions, how much it will be crowded. Yeah, that's the word I'm looking for. So as an example from one vertical, right?
Yeah, so I think if the question is what are the type of applications that the clients are looking for in the beginning, or it's also extremely different depending on what type of industry they're in, I would say. Looking at the manufacturing industry, they usually look at the manufacturing process, or maybe
maybe predictive maintenance, the word you were looking for.
That's one part of it. Yes, then the supply chain process.
Oh yeah.
So in order to optimize the supply chain or get a better overview of it, and the predictive maintenance has been around for forever almost. So very common in the manufacturing business. But in looking at, so if we look at consumer business to consumer related companies, they usually have a strong tendency, I would say, to lean towards customer analytics of many different kinds. But upsell is one, for instance.
Mm-hmm.
if you look at clients that have like millions of customers that have like millions of clients, like a mobile operator or something, churn is different churn models and so on. So customer, yes, but and it varies from industry to industry. In healthcare, it's not so much predictive maintenance.
Yes,
However,
but I
it would
think
be great. It absolutely can apply.
And I agree, because that's what I had in my head as well. That maybe this can be understood like that. That maybe, okay, like in healthcare, maybe we're more interested in looking into solutions like the convolutional neural network, or like do some like I don't know what else. My brain is so full with all the stories you were coming up with, and I would just repeat the stories you said before. So yeah, but you know what I mean. Stefan, do you have something to add?
Yeah, so I really agree on. There are a couple of ways you could provide value with machine learning. One of them is you have a process where there's a lot of revenue going through. There's a lot of value in like marginally improving that 1%. That's probably because Google is investing so much. Like improving ad efficiency 1%. That's a lot of money. But you also have totally different things that were not possible before. So for instance, like CNNs and image analysis, that opens up totally new things. Language models in the last couple of years have gotten really impressive, and that opens up for new things that we haven't seen before. So it's a combination of adding a couple of percent somewhere and doing totally new things.
Nice. We actually have a question here from the audience. So it's Gabriel. He asks, from your presentations, I see a lot of connection between IoT and real-world machine learning. Do you see this as a rising trend for the industry?
IoT is more and more like it's here for some time, and things are more and more connected. There are more and more sensors, and what I showed, like with this Percept device that Microsoft just released, I think this AI stuff is going to edge a lot in the next few years, and everything will be, not everything, a lot of things will be distributed to be able to react exactly there on that spot and performing specific action. So I do see this as big thing in future AI on edge.
Yeah, I also just absolutely. To me, IoT is there to provide data, and then you use machine learning and AI technology to derive insight from that. And what Percept and edge devices add to the mix here is the ability, to work wherever and get that combination wherever you are. Even without having an internet connection. You could be very far outside of the grid, having a chainsaw, cutting down a tree, and get a notification telling that the chainsaw will probably break in a while. So I think that it's a very good question, and I absolutely think that it's not just a trend. It's the way to go.
We are also very lucky with hardware developments. So these 3D cameras, they were a couple of $100 some years ago. Now you can buy them on AliExpress for a couple tens of dollars. LiDARs were things on self-driving cars that were very expensive. Now there are startups building them for like $1,000, $100. So radars as well. Lots of new tools coming out there.
Definitely, and I think it's great to see that this do-it-yourself community enthusiasts out there are, they trying out stuff, and basically a lot of innovation lives there, right? A lot of sensors, like, they're super cheap and out there, and it's really really great.
And it's also really helps that there's so much managed tooling coming out. So let's say you're an embedded developer. Okay, you know how to work with these devices, but you probably don't know machine learning. Okay, you have managed machine learning to get something out. And the same way, when I, as a data scientist, I know machine learning, but I'm not good with IoT. So I have someone to hold my hand there with the product. It allows me to get something out. And if it works, we can invest more in it, and then we'll move away to something more custom. But it allows us to demonstrate value quickly, cheaply, and then scale from there.
Yeah, so we have a last question for today, again from Gabriel. So the question is, what are your thoughts about TinyML and TensorFlow Lite? Is this something your companies are interested to explore to bring value to customers? Stefan, maybe you can start.
Yeah, I guess it's very interesting, this trend in compressing models to save on compute. And it's definitely needed in order to run more and more demanding stuff on the edge. I believe we're going to see more and more products in mobiles and also battery connected devices, and power consumption is very important. And typically we see that in ML, there's this trend of someone does something with like either an innovative use case or massive gain in improvements. They do it by like having deeper network, much more data, much more parameters. So that's like one thing. And then for the next couple of years, people are getting the same performance with lighter and lighter models. So that's what we saw with CNNs, like the first VGG networks. They were impressive, but they were huge. And then we've seen research continue with, can I improve things a bit more with huge networks? And can I have the same performance or better with smaller networks? And also, can I train my model with a lot of data in advance and then save on compute when I do inference? So it's definitely a focus on conserving compute, conserving memory consumption.
Yes, I completely agree with you, Stefan. Just to add to that, I would, in my mind, it's as IoT is expanding, and we as people also get more acquainted and used to measure things, because we are getting more and more used to that, not only in the workplace but actually off the workplace in our private lives. I think you will see this kind of technology grow into watches, mobile phones, I think actually shoes, for instance, maybe even clothing, and a lot of different other stuff. So I think there is probably a whole new economy that will maybe if I just kind of spin in my head, our economy will start to grow from there, or an ecosystem of new types of services at least.
Goran, do you want to comment on this?
I fully agree, and like question was like the second part would it be interesting to explore, to bring value to customers? I think that's the point, right? If it brings value, if it can bring value to customers, then of course this should be explored and checked, like what can be done with it, and how much value it brings.
Yes. Well, I am very happy that we could talk about so many things today. I actually learned a lot from you guys. And then I heard a lot of new things, for example, that I was not aware of. So it was really awesome to hear all these things from you. So I am very happy that we could host you, all of you. So thank you for tonight. I think with that, I'm going to wrap up for tonight. So because somehow these few hours just happened in like 2 minutes, but we've seen a lot of interesting topics and amazing speakers, and your journey doesn't have to end here. You can continue learning with the Cloud Skills Challenge until 10 a.m. on the 24th of September and be the lucky winner of one of the free AI42 swag boxes. And the cool thing actually about this skill challenge is that you will see a real life application of artificial intelligence and machine learning by practicing through the steps of what NASA is doing while they're analyzing moonstones and a lot more things that are very interesting. So I really think it's a good idea to look into this challenge. And then the winner is going to be picked on the 25th of September, and you can review the winners list on our webpage, which is going to be shared as well later on. So thank you all for joining us. Hope you had a great time with the AI42 team. And as our gratitude, please take our Azure Heroes badges with the help of this QR code. And we also hope to see you soon at our next event that is going to go on every second week on Wednesday until the end of the year. And we really hope to see you again soon. And with all that, I thank you again to all our speakers for the amazing night tonight, and to our audience, and to our speakers, and to our hosts again. Wish you all a great evening, and thank you for joining us.
Thank you, everyone.
Thank you.
Thank you.
Bye.